Hi everyone, welcome to my YouTube channel. In this video, I am going to explain you about the absorption cross section of copper using GM counter. So I have already explained how to operate GM counter and how to calculate operating voltage in the previous video. So please watch that video. So here the aim is to calculate the cross section of copper using GM counter. We are also going to do the cross section of lead using GM counter. So I have already explained that. You can also watch that video. So here the apparatus require GM counter, copper absorber and gamma source. Here is the gamma source. These are the copper absorbers. Okay, GM counter. So first thing you should understand what is cross section. That is the where the interaction between area at which the interaction between particle and radiation is going to take place. It has the dimension of area unit for cross section in terms of bar. So formula to calculate cross section for a given absorber is mu m into mass number divided by Avogadro number, square of that. So theory of this attenuation coefficient you should read. Attenuation means what? Decrease in the intensity of radiation or the decrease in the counts. As the thickness of the absorber increases, count rate is going to decrease. So I will explain you how to do this experiment procedure, and this is the diagram for working of GM counter. Okay, so first thing you should note down here the observation. Okay, for this you have to write down operating voltage of about 550 volt, and the time you are going to take 20 seconds, and the source used is gamma source. Okay, absorber copper. So here I will show you. First you should go whatever the inputs you will provide, go to the program and set the time and voltage. You can set the voltage using this knob. 550 20 second, and paralysis time must be off. You should check that. Okay, it is off. Then say store. Okay, and here you should note down the background counts without source. Okay, just click on start to note down background counts. Once backgrounds are going, counts are going to be very less in number because without source we are taking. Just note down that. Then what you have to do here the four thicknesses that we are using. First make the tabular column for four given thicknesses. Already they have been measured, 0.032 increasing order. Okay, then what we have to do next is here the background counts we got is around 11. Note down that. Next what we will do here, we will keep the source here in the source holder, and the counts are going to depend upon the distance. If you keep near, counts are going to be high. If you keep little bit far in the fourth or fifth slot, the counts are going to decrease. And here first I will keep the first thickness. The number also has been mentioned here. So this is the first. So keep it, this absorber on the source. Okay, then click on start. So for first thickness, how how many counts you will get, just note down that. So here we got about 319. Just note down the value here. So here I have changed the slots so to get the reading properly, and here for 22nd we got of about 257 observed counts. So just note down for this thickness they got 271, so near to that. And counts per second you can calculate dividing by 20, 271 by 20, here 257 by 20. Then take the ln of this counts per second, then calculate and repeat the same procedure for other three thicknesses and calculate the ln n. Plot the graph of here ln n versus t like lead. Okay, then you will get the slope, and here they got the slope of about 0.35. Okay, to calculate cross section you require mass absorption coefficient, that is mu by rho, mu by density. Mu is linear attenuation coefficient. 0.35 divided by density of copper is how much? 8.96. So after getting the mass absorption coefficient you can calculate cross section, substitute the values, and you will get the cross section of about 4.1 barn. So barn is the unit for cross section. 1 barn is how much? 10 to the power minus 24 centimeter square. So you can write the result here. The absorption cross section of copper is about 4.1 bar. This is how you can perform this experiment using GM.